You are listening to the IoT for All Media Network.
Hello, everyone, and welcome to another episode of the IoT for All podcast on the IoT for All Media Network. I'm your host, Ryan Chacon, one of the co-creators of IoT for All. Now, before we jump into this episode, please don't forget to subscribe on your favorite podcast platform or join our newsletter at iotforall.com/newsletter to catch all the newest episodes as soon as they come out. So, without further ado, please enjoy this episode of the IoT for All podcast. Welcome, Evan, to the IoT for All show. How's your week going so far?
It's going good. We're just getting started Monday morning here in California.
Fantastic. But thanks for being here. Really appreciate it. I think it's going to be a fantastic conversation. I wanted to start off by just having you give a quick introduction to our audience about yourself, background, things that are interesting, kind of how you ended up at Twilio, what you do at Twilio, that kind of thing.
Sure. So my name is Evan Kumak. I'm the general manager for IoT at Twilio. And I've actually been at Twilio for a long time. So coming up on about 10 years. So when I joined Twilio, wasn't doing anything really explicitly or intentionally in IoT. I started the IoT business unit about 4 years ago with a colleague of mine, Chayton, and we've sort of grown it since then, expanded the product portfolio, and just listened to customers, observed what the challenges they're having, and tried our best to solve their problems.
That's great. So, what kind of prompted the move into IoT? I mean, obviously, most people are familiar with Twilio for what you all have done for many years to grow into the leader that you guys have, that you are now. But what prompted the move to IoT? What was the reasoning behind it? And kind of just describe the overall role you all play in the space.
Twilio, for folks who aren't familiar, has been around for about 12 years, and we made our name providing APIs to developers for really telecommunications functionality or communications functionality. So we are at this point the largest SMS API provider in the planet. For example, we started out with voice and providing APIs for automated voice calling, and moved into other things through our acquisition of SendGrid. We're the largest email API provider in the world, and various other sort of communications mechanisms. The company's also expanding a lot into higher level customer engagement products. So we have a product called Flex, for example, which is a contact center agent side product. And we have a whole suite of products around how companies, in particular, companies selling to consumers, actually interact with their customers. In the process of building those products over the years, Twilio really built a strong competency in interfacing with mobile network operators. So, for example, you can log into your Twilio console, you can buy a phone number in over 100 countries, and you can start using that phone number via APIs to send and receive SMS messages, for example. And so it was that competency in interfacing with mobile network operators, MNOs, you may hear me call them, that led us down the IoT path. And the reason for that is we looked at what was happening in cellular IoT in particular. And what we saw was that customers were essentially buying directly from mobile network operators, buying network access. And they were doing so using software that the mobile network operator was buying from a software vendor. So say someone like a Cisco, which has a product called Jasper. Mm-hmm. And when we looked at that model, I guess what we saw was that there was sort of a bit of a conflict here in terms of the prioritization of the customer roadmap and what was being delivered to customers. It tended to be a sort of an MNO-centric worldview. And what that meant for customers was that if they really wanted to deploy something globally or at scale or get something out the door very quickly, it was quite difficult because dealing with mobile network operators tends to be difficult in the first place, but secondarily, mobile network operators are sort of inherently regionalized. They're not global in their nature. And so that kind of led us down that path of us saying, okay, well, could our business model of buying assets or network access in a wholesale manner from mobile network operators and then hooking it up to a global cloud-based software platform and exposing that functionality via APIs to a long tail of developers, could that model that we'd been doing for so many years on voice calling and phone numbers and SMS, could that be applied to cellular IoT access? And of course, the answer is that yes, it can. And so that's the products that we've been mostly focused on building for the last few years.
Fantastic. Yeah, to kind of elaborate on your products a little bit, I was looking around and I saw two things that stood out. One was the narrowband IoT platform. The other was SuperSIM. Could you talk a little bit more about what those two are? I know SuperSIM seems to be more of your flagship IoT product. But the narrowband IoT platform seems really interesting too, because it seems like it's built kind of specifically for developers. So could you elaborate a little bit more on what those two kind of offerings are?
Sure. So when we first got started, we wanted to get to market quite quickly, and we wanted to deliver on a few promises. So we wanted to deliver on being able to get customers to market quickly, being able to have a sort of self-service sign up, no NDAs, no contracts kind of pricing model. And so we built our first product very quickly in partnership with T-Mobile in the United States. And that product was called Programmable Wireless. And that gave our customers access to T-Mobile's network in the US. It also gave our customers access to all of T-Mobile's partner networks around the world, but it still didn't completely fulfill all of the promises that we wanted to fulfill. So, for example, we still ended up, without global internet breakout infrastructure. So, if you were deploying devices in some other part of the world, the data would route through the US, and this is typical when you deal with any mobile network operator. Typically, they only build their back-end network infrastructure in the country in which they operate. But as part of that programmable wireless product, we also got access to T-Mobile's narrowband network here in the US. And one of the challenges with narrowband right now is it doesn't work so great. And when I say narrowband, I'm talking specifically about 3GPP NB-IoT networks. They're not set up so great for sort of global deployment. It's pretty early days, and typically you have to get a SIM from a specific network operator in order to operate on their network. And there can be a lot of other sort of challenges that the mobile network operator might put in place in terms of you actually getting active on their network with device certification and device registration and all this kind of stuff. But basically, our first generation of products, there was two variants. There was programmable wireless, which was a standard 2G, 3G LTE SIM built in partnership with T-Mobile. And there was our T-Mobile narrowband SIM, which gave customers access or gives customers access to the T-Mobile narrowband network in the US. Once we had that product out to market, we really invested heavily. We did an acquisition of a company called Core Network Dynamics, which builds what we call a mobile core, which is essentially the back-end services that run a mobile network. And we acquired that company and we deployed our own mobile network essentially in the cloud. So we basically run a globally distributed cellular network, everything but the towers to a certain extent. There's some technical nuances there, but basically we run the back end of a mobile network in Amazon primarily. And what that allows us to do is to build the other product you mentioned, SuperSIM. And with SuperSIM, what we do is we partner with tier one sort of families of mobile network operators around the world. So companies like Telefonica, which have a huge footprint of different global networks around the world. And we, other companies like Hutchison as well, very similar. We basically buy wholesale connectivity from them for their networks and for their partners' networks. And then we built a single SIM, and that can be a SIM card. It can be an eSIM profile. It can be an embedded SIM. And that SIM essentially connects to our mobile network in the cloud and uses the best connectivity at any point in time based on where the device is, the type of network you're trying to connect to, et cetera, et cetera. So SuperSIM is really where the Twilio model came out, and we were actually able to build the architecture that we'd been offering for SMS and voice for those number of years.
Right. That makes a lot of sense. Okay. And attached to those two kind of offerings, or you can expand into anything you want to talk about here, but are there any particular use cases you can share with the audience that would kind of just bring it all full circle into some real life examples of how you're, involved in the solution side of things?
So obviously we started down the road in cellular, and I think cellular IoT is really interesting for a very specific reason, which is that when I think about the future of IoT or the near future of IoT in particular, the thing that comes to mind for me is really people providing new services. So basically, we think about IoT in the home, which tends to be Wi-Fi centric. And oftentimes, although there are services bundled with the devices, the consumer really perceives themselves as buying a device, right? It's a better security camera. It's a better thermostat. It's a better connected version of whatever it is. It's a connected toaster, et cetera, et cetera. Outside the home, you see this sort of business model innovation where companies are what you might describe as like servicifying things. So we had a lot of early success, for example, in micromobility with the scooters and shared scooters and bikes, companies like Lime. You can think of that as like a servicification of last mile transportation within a city. We have other companies. One that I really like as an example is called Pulsa Sensors, Pulsa. And what Pulsa does is they build little sensors that sit on gas tanks or scales that sit under certain types of gas tanks. And they're not really selling the sensor, though. What they're selling is this big cloud algorithm that basically does predictive analysis of when you're going to run out of a certain type of gas. So they sell and lease these devices to companies like welding companies and dentists and bars. But really, they're actually providing it to the company that is in charge of refilling that substance. And so what they find is that instead of once a week, if a truck rolls around and refills all of the bars with their CO2, instead, that company providing gas can now just go to just the folks who need it at just the time they need it. And they actually change the nature of their business to be this sort of just-in-time, real-time delivery of gas. And we have other companies doing this with a company called Sensonio, for example, does this with trash collection. So instead of a truck driving around on the same route every Monday, emptying dumpsters, they dynamically generate a route for the driver to go and empty just the dumpsters that they know need filled or they suspect will need filled shortly.
Gotcha.
So we have a lot of these use cases of sort of servicification of business use cases. And I think to me, that's like the really exciting part of IoT.
Yeah, I mean, I think there's a lot of opportunity there. Like we've seen a ton of kind of at least literature and articles and use cases written around smart waste monitoring solutions. So it's great to see you all working on and deploying those types of solutions, because I think there's a lot of opportunity for growth that is very applicable to not just our audience but just the industry as a whole. So that's fantastic. I want to pivot for a second and just talk about kind of just the overall approach you all have made. Obviously, going from kind of moving into the IoT space, you've had probably a pretty good opportunity to observe what's been going on in IoT for a number of years before Twilio kind of moved into it. And I'd be curious to kind of get a sense of what is the approach you all have taken. It seems like a more developer first approach when you're talking about providing that infrastructure building blocks to builders. So I wanted to just get a sense of how you all view that approach and that philosophy behind your move into IoT and bringing the offerings to the market that you have already.
So you're right. Twilio is a company that is built sort of by developers for developers, let's say.
Right.
And we have many millions of developers in our broader community as a company building with our other products. The thing that struck us about IoT is, and it's kind of interesting, it's still this way, I think. It would appear that you have a small number of quite large companies that are doing very well, maybe better than even we anticipated. So, companies like Amazon and Google appear to be shipping lots and lots of devices, and consumers are certainly going after them. But when you look at like the real economic transformation sort of potential of IoT, and you start to talk about those use cases like, the ones we just talked about with refilling gas and things, Google and Amazon are not going to presumably go after these opportunities. These are they're big opportunities, but they're not gigantic opportunities. They're not at that sort of mega scale. And so what you really want is you want to enable many developers to go out and try things, to go out and experiment, to go out and see what works, and understand that many of those things will fail. And that's okay. Some of them will succeed. And I think that mentality exists very strongly in the software community. That's sort of almost taken for granted. And you see it in the venture capital model that supports Silicon Valley and Silicon Valley's sort of software-centric backbone. But it does appear that that's still sort of not quite there in IoT, in the sense that it's still sufficiently difficult to go and sort of get to a point with a product innovation or service innovation where you can get that active feedback of, did we succeed or did we fail? What do we have to iterate on? What's wrong with the business model? It just seems like it's still sufficiently difficult to do that such that, I don't think we see that same level of innovation through experimentation. And so it seems inevitable that we will get there. I'm not it's impossible to say with 100% clarity what that looks like in the future. But, Twilio, we want to do our part. And so we're basically just looking at the problems that are disproportionately difficult or prohibitively difficult in terms of getting to that experiment phase, that proof of concept, that proof of value phase, and trying to apply our platform's knowledge to solve some of those. And, since we launched the connectivity products, the cellular products I've talked about, we've actually expanded into some other things as well, which is really strongly based on that philosophy that I just mentioned.
So let me ask them, when we're talking about innovation and kind of the rate of innovation in IoT, and let's say we start thinking about how it compares to other industries, other software industries and so forth. So I know you kind of already mentioned why IoT is maybe not attracting the same innovation at the same rate, but what do you think, aside from what you all are doing in the market, what do you think the market needs in order for innovation to kind of get to that same level that we're seeing in other software related industries? So basically, what can be done to improve or change why the IoT industry is not attracting that same level of innovation that you're seeing elsewhere?
I think at the end of the day, it comes down to some sort of fundamental question, which is very difficult to answer, which is, can that ever be the case? So, I think of IoT, all the buzzwords removed, really what IoT is about is single purpose computing. So we had this sort of general purpose computing revolution that started in the 1950s with mainframes, or even before that with sort of very large computers, UNIVACs and things. And over time, you basically just innovate on this single piece of hardware or single hardware platform, which is a general purpose computer. And you end up at something like, the iPhone 12 or whatever you want to look at. But throughout that whole process, software developers have been able to take that one piece of general purpose computing hardware and write software for it to solve a whole range of different problems that no one could ever have anticipated. Famously, the UNIVAC was designed for doing things like missile trajectories, but famously on television, it was used to, software developers used it to predict the outcome of a very early presidential election. And that kind of blew people's minds. You look at the iPhone, it's got all this hardware and a GPS, and now it has LiDAR and all these different things. And software developers can take that stuff and say, okay, here's a new use case. Here's Uber. Probably Steve Jobs did not think about Uber when he was, pushing his team to build the iPhone. And when you go to IoT, there's this fundamental change, which is you go from general purpose hardware to single purpose hardware. So now you're saying, in order to solve some specific use case out there in the wild, whether it's monitoring trash or whether it's some sort of shared transportation, it's implied that you're going to have to design and build hardware for that use case before you can build the software. And so that's a considerable uphill battle for innovators, I would say. And so there's probably two things that can happen there. One is over time, one of many things. One is over time, the community gets better. And, you do see things starting to pop up now, like hardware academies and things that, make it easier for people to build their first hardware device and actually get it manufactured and certified. The second is that you end up with hardware that is slightly more general purpose than it needs to be. And this is something that I'm sort of excited to see happen in the ecosystem where, for your first 5,000 or 10,000 devices that you build to satisfy a certain problem, does it really need to be the lowest possible BOM? Mm-hmm. Does it really need to be, hyper customized in terms of its appearance? Or could you use some hardware that's, slightly more generic but still solves for your use case? Maybe it's slightly more expensive, and then you invest in customizing it more later. So I think there's lots of ways that problem could solve itself. But I think that's ultimately the challenge is when you go from general purpose hardware to single purpose hardware, there's just that additional very steep uphill climb that any innovator has to take on before they can prove value.
So as you were mentioning their challenge, how that's, one of the biggest challenges. I'm sure there are a number of other challenges that are associated with that particular piece, especially on the hardware side. And I wanted to see if you could address them, or at least give me your thoughts on how big of a challenge they actually are, and what kind of advice you have for that, to help overcome them. So one of them has to do with security, and the other is a little bit more about the software side, installing software on the device. But the first thing I wanted to hit on was how do you approach, or what do you think about when it comes to ensuring security throughout the device's lifetime? So obviously the building the hardware compared to the software is always a challenge, but there's that security element that we talk a lot about. And, we talk a lot about the focus on making sure security is a thought early on in the development process rather than an afterthought, brought down, kind of more thought about down the line. But from your side of things, how big of a challenge is it to ensure that security is kind of thought about throughout the entire device's lifetime, and being able to handle that challenge? Like, how do you approach that, or how do you think about that for something that the industry can, solve? Because I think this all leads to more adoption and more innovation if we're able to solve some of these other challenges as well.
Yeah, couldn't agree more. When we got into the space, we had not really had an opportunity, as a company at least, to see how a lot of people were building these types of devices and solutions. And all of a sudden we had this, purview into what people were building. And I think one of the things that shocked me, at least personally, was how much of everything that the embedded audience and folks making devices are still sort of rolling themselves quite often, or at least, maybe they're using some APIs provided by a module, a cellular module or something like that, maybe a Wi-Fi chip, but they're still rolling a lot of things themselves. So things like certificate management and identity provisioning and various things like this. And, it may be that comes from embedded culture. I think in embedded culture, especially when you had a history of like highly constrained hardware and, energy, of course, is very precious, that, building things yourself was a more respected path to take than what you would think of in, like, say, the cloud computing world, right, or mobile or desktop. You would never start your new website project by creating your own Unix implementation. So in the cloud world, for example, it's just more taken for granted that, like, hey, we have these good platforms that have been tested for a very long time and we should adopt them. And what we saw when we got started was sort of the opposite, was people rolling their own security and rolling their own various things. And so that actually led us to, we kind of hypothesized throughout last year, really, that this was one of the biggest problems facing the ecosystem in terms of moving quickly. And so we actually acquired, at the very beginning of this year, a company called Electric Imp, which had been making essentially an operating system for embedded devices that provides managed security, managed cloud communications, and some other functionality as well. We acquired that company earlier this year with the idea that, like, hey, this is probably the next biggest category of problem where we can have a meaningful impact based on our, based on our historic sort of strengths as a company.
Yeah, it makes a lot of sense. So this kind of leads me to an interesting question when you're talking about kind of building from scratch versus not building from scratch. So how do you advise companies, or what is your approach when it comes to having to choose between, the full stack IoT development platforms or having to create kind of the platform code themselves, neither of which seem to be obviously very desirable for embedded software engineers, from what it sounds like I've heard in the past, kind of what you're alluding to here. So how do you approach that type of challenge, not just in what you all are doing, but just as the market as a whole? I
love the way you phrased that question, because that's sort of how we thought about it as well. So we looked at the market, and there was two options, it seemed, for developers. One is build everything yourself, and the other is go and trust one of these like very high level full stack platforms, of which Electric Imp is one. And there's definitely benefits to those platforms, especially if you're not a highly opinionated embedded engineer and you're sort of willing to do things a different way, or maybe this is your first device you've ever created, or you're working at a company that is building an internal sort of product, and don't necessarily consider yourself to be an IoT company, first and foremost. So there's definitely value in those high level platforms, but I agree with you that the adoption just didn't seem to be there in huge numbers. And so we looked at that, and when we took on the Electrichem team, we asked and sort of posed the question to that team of how could you create a platform that like more resembles in terms of value propositions something like what Amazon EC2 offers in the cloud, which is, if you're a cloud developer, Amazon EC2 solves all of the stuff that is completely non-differentiating. No one wants to lay electricity cables. No one wants to lay networking cables. No one wants to manage swapping out failed hard disks. But it doesn't force you to completely change the way that you build software. You can load Linux on there. You can load Windows on there. And then you can sort of run your code that you've written historically for Linux or Windows. And that led us to a product actually we announced a few months ago, which we're calling Microvisor. And what Microvisor is it's essentially a platform that runs on ARM Cortex-M chips that support a hardware isolation technology called TrustZone-M. And so what we do is we run a piece of code in a secure enclave in the microcontroller. And we provide to you the services that we talked about. So things like security management, certificate management, secure connections to cloud servers, software OTA updates, even remote JDB debugging. But we do it in such a way where the goal is that your code that you're writing to run on the microcontroller, you can write it the way that you would always have wanted to write it. So you could use FreeRTOS, or you could just write your native code, or you can sort of do what you please. And that runs alongside our Microvisor. So we're providing those services to you, but not saying, hey, by the way, you have to forget everything you've ever done in the embedded world.
Mm-hmm. That makes sense. Okay, great. Last question I wanted to ask you before we wrap up here is regarding kind of the safety and the reliability of deploying software or even operating system side of things, updates to a device. So that's something that we've seen as a challenge at times. And I'm curious through your lens, how you see that in the market, how you see that as a challenge, and how you kind of believe we can approach that to kind of make that a little less of a challenge than maybe it is right now.
Yeah, I think that probably comes down also to the same sort of idea that I was just mentioning, which is everyone needs that functionality. I mean, one of the promises of IoT over historic embedded computing is the notion of agility. All of a sudden, you get that same agility that software companies have become used to. But agility means deploying, frequently, and so in that regard, if everyone's doing it and it's sort of such a popular thing to do, the idea that folks would invent their own OTA platform seems a little crazy to me, because you just never be able to put as much automated testing into it, or as much engineering effort into it as a platform provider will, who's providing that service to potentially millions of developers and millions of devices. And so we have, with Electrichem, we have an OTA ability, and with Microvisor we have OTA ability as well. And we just really spend a ton of time on automated testing, and sort of we're actually publishing a white paper very soon for Microvisor that covers how we treat this at a very technical level. But I think fundamentally there, it doesn't add up to me that this is something that individual device makers should be having to reason about. It's just such a common thing. And so again, I would say this is one where I don't think it adds particularly unique value. And as such, like, not worth spending your time on. This is something where a good platform provider is probably what you want. Okay.
Fair enough. Appreciate that. These insights have been incredible from my standpoint. So I appreciate you taking time. I wanted to wrap up here by asking you if there's anything that we should be paying attention to, kind of coming out of the Twilio IoT side of things. Anything you're excited about, maybe just happening in the industry in the next number of months going to the 2021 that may be worth mentioning here as we're finishing up. And then in the same breath, if our audience has questions or any follow up to anything we're talking about here, what's the best way to kind of engage?
Sure. I mean, in terms of what to look forward to, I think, obviously IoT development cycles are really long. And so, we've been in the market now for about 3.5 years in terms of having actual products out. And, SuperSim really only was in customers' hands as of sort of earlier this year. But the thing I'm most excited about is we get to see a little bit into our customers' roadmaps and what they're building ahead of time. And, I really do think that within the next sort of 12 to 18 months, maybe less even, maybe 9 to 18 months, you're going to see a lot of what I would define as startups, companies you've never heard of, building devices that connect to cellular networks globally at very large scale, beginning to roll out devices and sort of fulfill on some of the promises that we've been talking about for a long time, but which we haven't really been able to show off because the pipeline of development takes so long. In terms of features and functionality, I think we're pretty set on iterating on what we have. We want to keep adding more geographies and better networks to SuperSIM. We want to keep adding features and stability to both Electric Imp and to Microvisor. So we're pretty set there, we think, for the next little bit. Although you should expect to see more partnerships with hardware vendors and other folks. And if there is anyone in the hardware ecosystem or anyone just looking to build a device, a solution, you can reach out to. Probably the best place to go is just if you go to twilio.com/IoT, and you'll find various ways to contact us there. If you want to reach out to me personally, it's just my initials, EC, so Echo Charlie @twilio.com, and I'll do my best to facilitate the best conversation. And yeah, that's probably what I would say. We're again super excited to hear from any hardware vendors that, like I say, want to do partnerships, any device makers, and we do have professional services, and we have teams that can help you to make your solutions a reality as well.
Okay, fantastic. Well, Evan, this has been great. Appreciate all those insights. I appreciate the information there at the end. We'll make sure we get all that out to our audience in the description, in the notes, so that if anybody has any follow-up questions or wants to kind of stay in touch with you or Twilio, they can do so. So again, thank you so much for your time. I really appreciate it. I think our audience is going to get a lot of value out of this conversation, and it's always great to hear from a leader in the space. So thanks again.
Thank you so much.
All right, everyone. Thanks again for joining us this week on the IoT for All podcast. I hope you enjoyed this episode. And if you did, please leave us a rating or review, and be sure to subscribe to our podcast on whichever platform you're listening to us on. Also, if you have a guest you'd like to see on the show, please drop us a note at ryan@iotforall.com, and we'll do everything we can to get them as a featured guest. Other than that, thanks again for listening, and we'll see you next time.